in psychology, but because his law is true, you might have forgotten what it meant, right? Because it says if you learn something at a certain level and then you don't rehearse it, if you don't use it, it atrophies. You forget the information. So he says the Ebbinghaus's law of forgetfulness states that if a task is learned at a performance level of P sub O, sub O means originally. So you made 100 on a test, you made a 90 on a test, let's say. Then after time, interval of T, the performance level P. So P is your performance at time T, right? So let's say P sub O is 100, and then you let a year go by and you don't rehearse, and you take the same test again. P is the grade you get after 1 year, so on and so forth, okay? It's a log function, and just like most social scientists and scientists do, it's in terms of base what? 10, right? So where does C? C is an empirical constant that varies from whatever you're doing, from the task at hand or the subject matter, okay? T is measured in months, it says. So it says to solve for P, right? So let's go ahead and write it down here. I would need to manipulate the expression. So log P equals log of P sub O minus C times log of T plus 1. Okay, so this is definitely a log equation. And we have several unknowns in there, don't we? We have P, P sub O, C, and T. So we have 4 unknowns. This is what I called not just a formula, but do you remember what it's called? Instead of a formula, mathematicians literally call it a literal equation, okay? Literal equation, literal means by the letter. So a literal equation is just an equation with lots of variables in it. You should be able to manipulate a literal equation, right? That is, manipulate symbols. That's what algebra is all about. So that's what we're going to do here. We're going to solve for P. So here's P right here. I got to get the P by itself. I got to isolate P. So how are we going to do that? Well, let's see. I have log base 10 of P already on the left. So if I can condense the right side, because it has 2 terms, then I might be able to equate one log function to another log function, or log expression to a log expression. So let's do that. Let's leave the left side alone, and we'll condense the right side. Now remember, to condense, the coefficients have to be 1 or -1. Am I at that point? I have a 1 in front of the first term, but I have a C in front of the second term. How do I get rid of the C? Well, the negative's fine because I can condense and divide. But what do I have to do with that C? There you go. Property 3, I need to bring it on up, right? So this becomes log base 10 of P sub O minus log base 10 of T plus 1, all to the Cth power, to the power of C, right? Very good, Daniel. And now I have log base 10 minus log base 10. So on the right-hand side, I can condense by pulling 1 log out front. I have at least 1 negative term, so build that shelf. Yeah. Okay. Now remember, the log is out front. It's the argument that becomes the quotient. P sub O, we say. P sub O over to the Cth power. Yeah. And that equals log base 10 of P. Now, because I have log base 10 equals log base 10, I have 2 options here. I can either algebraically exponentiate both sides base 10, right? And then 10 to the log base 10 of blob is blob, or we've done it so many times with exponential, we can get the bases the same or use the GTBTS method, right? Which says when the bases are the same, you can equate the exponents. Well, logs are exponents, so we can here also equate the arguments. So P equals P sub O over T plus 1 to the Cth power. And there it is. I solved for P. I completed the task at hand. Now, if you want, you could actually write this as P of T, because P sub O, we're going to know, and C, we're also going to know for the particular task at hand. So T would be my independent variable. If I know I took a test and got 100, then after 1 year, and C we would know for the task, I can plug it in, right? So let's go ahead and do part B then. Part B says, if you scored a 90 originally, what would you expect to score on a similar test after 2 months? Okay, well, that's going to be P of 2. And let's go ahead and plug it in. It says to assume C is 0.2. So P of T for this particular task, it could be maybe your test tomorrow, right? P sub O is a 90. Would you be happy if you made a 90 on tomorrow's test?
Yes.
No.
You're always happy to get passing grade.
What? No, we strive for more than that. All right.
Yeah, like it's always happy to get a passing grade.
Well, I guess on the lowest level of happiness. Yeah. Right. So here it is. So let's say on tomorrow's test, the C value is 0.2, and that's a value that's calculated empirically from data, but you made a 90. So now I want to know what we get after 2 months. So that would be like maybe on your final exam, right? You make a 90 on tomorrow's test, and then as part of your final exam, I give you the same test 2 months later. Oh, P of 2. No, it's set up here in months, right? Months. Okay. So P of 2, 2 months. Now, what would you expect to get? Hopefully, you think you'd do better if you didn't rehearse. That's very unlikely, right? If you get the same, then you have a steel trap mind, they say, right? You just don't forget anything. But more than likely, it's going to be lower. So let's plug it in. 2 plus 1 to the 0.2th power. And I have a calculator right here. I'm not going to bother loading my calculator on the screen. So I'm just going to go 90 divided by 3 to the 0.2 power. And you think you're going to pass after 2 months? You made a 90 the first time. You think you're going to pass? No. According to Ebbinghaus, you make a 72.246, which of course I'll round down to a 69. Oh, all right. So yeah. So yeah, you did pass, right? It makes sense. Now, what would happen after a whole year? How many months is a year? 12. So again, we got to make sure the units line up. You think you're going to pass now? Probably not. A whole year later, right? A whole year later. Let me see. You get 90 divided by 13 to the 0.2th power. Oof. You get a 53.883, which may not be bad, right? May not be bad. Right? You graduate from heart surgery school and you made a 90 on your final heart surgery exam. And then, you go off to Aruba for a year on vacation. You come back a year later and you do your first heart surgery. And now you're good at your 54% good.
That's over half.
Right? Yeah, it's over half. You're just happy if you're over half, right?
That is how I got my medical license.
Yeah, there you go. Right. Okay. And I don't know why I said Aruba, but it seemed appropriate. Anyway. So there you go. So that's an application. It's not just like science, right? But we call that social science, where we study human behavior. Yeah. Is that the forgetting curve? Yeah, it's the same thing. Yeah. Ebbinghaus's law of forgetfulness. Very good. You did not forget that. Yeah. All right. So the last thing I could do, which is on your worksheet, is describe how we can, how the graph of log base 1/2 of x can be transformed to become the graph of log base 6 of x. All right. Now, before I start this, I just want to tell you that the test tomorrow is 4.1 to 4.4. It'll be no calculator. It'll be the standard form. You'll have like 9 multiple choice questions and 1 free response question. Where can you go to practice if you want to see what it might look like? Old tests link under Corpy's World, right? 4.1. There might be a test that goes through 4.5. You can, we're not going to go that far. 4.5 is just solving equations that are extra spicy. So if you see a question and you're not sure, You know, it says to solve for X and it doesn't look like anything we've done. It's probably not going to be on the test. There's other tests that go through 4.4, so you can practice that, or you don't have to practice at all, right? You can come in with Ebbinghaus's law of forgetfulness and score 58 to 53 the first time around, right? Right, because that's what honor students do, right? And then I just rely on the retests, right? No, we're not happy like that. All right, so this is a nice application of the change of base formula. If I start with log base 1/2 of X, first of all, is that logarithmic growth or decay? Logarithmic decay. Good. 1/2 is less than 1. So it looks like this. Possibly, right? We'll call that f of X. I want to know what it looks like, what I have to do to get the graph of log base 6 of X. Now, is log base 6 going to be steeper or less steep than log base 1/2?
Gonna be steeper, but going.
Not really. No, remember for logs, if you look at the magnitude, like 1/2 is really like base 2 flipped, right? Base 2 is actually steeper than base 6. Because remember for logs, the bigger the base, the less steep the graph, or the smaller the base. So base 6 is going to come in here and it's going to be flatter. Okay, so there's G of X. So if you think about what I have to do graphically to start with the green and get the purple, the first thing that I know, obviously, I'm going to have to do is reflect it. Yes. If I reflect F across the X-axis, that's going to be a good start. All right. So remember how we reflect across the X-axis? We put a negative in front of the function. But then I'm going to have to vertically compress it. Yeah. By a factor of question mark. Well,
Wouldn't it have to be like 12?
no, it's basically log base 2 of X flipped. Okay, we talked about that. So here's how we could figure it out exactly. All right, I want to take log base 1/2 of X, and I want to turn it into log base 6 of X. Now, if you notice, the two things I'm going to have to do, a reflection across the X-axis and a vertical stretch, they're both tied up in the same variable of transformation, right?
So
A. They're both tied up in A. So if you put A in front of the one we're starting with, all you got to do is solve for A. Well, look how easy this is. If I solve for A, I'm going to divide both sides by log base 1/2. So I get log base 6 of X all over log base 1/2 of X. And now let's use the change of base formula. It's the natural log of X over the natural log of 6 divided by the natural log of X over the natural log of 1/2. And then I'm going to state change flip. Watch this. I got a complex fraction. The natural log of X over the natural log of 6 times the natural log of 1/2 over the natural log of X. And what happens with your natural log of X's? No, Brady, you do that every time. You're trying to give me a heart attack. They divide out. So you get log base 1/2 over log base 6, or natural log, I should say. And that's your answer. That's the number, right? Now you could put that in different versions. You could say it's natural log of 1 minus the natural log of 2 if you expand the top. But let's put it back as another log. That would be log base what? 6 of 1/2. Is that the same as negative log base 6 of 2? It is, because 1/2 is the same as 2 to the negative first, and then you can bring that negative out front. So this makes a really good multiple choice question on your test tomorrow. Okay. There is a question on the worksheet like that, but you're just going to use the change of base formula.
So
Now notice when I put log base 6 of 2 there, the negative is what I expected it to be. It's going to flip it. And then 6 to what power is 2? It's less than 1, right? So it's going to be a compression. Yeah. All right. There's just a few seconds left. Great day today. Try not to get stuck in at all today. All right. Have a great day. And check out the dumpsters after school. If the buzzards leave anything, it's yours.